On August 12, 2026, the sun will sit just a few degrees above the European horizon before the sky rapidly darkens into a deep midday twilight. The path of this eclipse sweeps down from the Arctic, crossing Iceland and northern Spain. For the Spanish mainland, it marks the first broadly visible total solar eclipse since 1905. Because a solar eclipse strictly happens during a new moon, the skies that night will be exceptionally dark. This perfectly aligns with the peak of the Perseid meteor shower, creating an ideal, moonless backdrop for viewing falling stars. The combination of a low horizon totality and an unobstructed meteor shower makes the August 2026 geometry an exceptionally rare visual alignment. To understand why this visual alignment happens at all, we have to look at the precise orbital mechanics that allow the moon to perfectly cover the sun. The math comes down to a strict ratio. The sun is roughly 400 times wider than the moon, but it is also sitting roughly 400 times further away from Earth. From the ground, the two bodies appear exactly the same size. Physics does not require this ratio. It is a strict coincidence, and we live in a narrow window of Earth's history where it is possible. Measurements taken by bouncing lasers off Apollo-era reflectors show that the moon is actually drifting away from us. Tidal friction between the Earth and the moon pushes it outward by about 3.8 centimeters every year. As the moon recedes, its apparent size shrinks. In roughly 600 million to 1 billion years, it will appear too small to block the sun, making total solar eclipses physically impossible. Every total eclipse we observe is a strict consequence of our specific epoch in planetary history. When that alignment occurs, the moon casts a massive umbral shadow that races across the Earth's surface at over 1,000 miles per hour. This fast-moving darkness has historically given astronomers the exact conditions they needed to prove major scientific theories, elevating figures like Albert Einstein to global fame. During a 1919 eclipse expedition, researchers photographed stars in the Hyades cluster sitting behind the obscured sun. The data showed that the sun's mass literally bent the light of the background stars, proving Einstein's theory of general relativity. Decades earlier, during the eclipse of 1868, astronomers analyzed the sun's outer atmosphere, the corona. They identified a bright yellow spectral line belonging to an element that had never been seen on Earth, eventually naming it helium. The moon's shadow serves a mechanical purpose. By briefly removing the immense glare of the sun, it provides humanity with a temporary laboratory to decode the physics of the cosmos. This mechanical precision extends backward into antiquity. Because the moon's orbit is highly predictable, ancient records of eclipses from 585 BCE and 763 BCE act as absolute chronological anchors for human history. This chart plots ancient Babylonian and Chinese eclipse observations against modern calculated eclipse paths. The visible discrepancy between where the shadow was recorded and where perfectly uniform math says it should have been is known as delta T. It proves that tidal friction is actually slowing Earth's rotation, lengthening our day over millennia. While the shadow measures deep time, it also triggers immediate local environmental changes. Air temperatures directly under totality consistently drop by 5 to 10 degrees Fahrenheit. Viewers often report strange animal behavior, like crickets chirping or birds roosting midday. However, rigorous comparative studies from 2017 and 2024 indicate that much of the extreme animal anxiety observed during an eclipse is actually a reaction to the cheering and chaos of human crowds, rather than the celestial event. The umbra is a multifaceted disruptor. It acts as a long-term cosmic timekeeper while simultaneously driving measurable, immediate changes in local weather and local biology. To safely observe this astronomical mechanism, you have to actively override your own biological instincts. Staring directly at the sun causes solar retinitis. High-energy ultraviolet and blue light enters the lens, which focuses it like a magnifying glass directly onto the central fovea, generating free radicals that destroy the photoreceptor cells in your retina. The human retina has absolutely no pain receptors. A viewer will not feel a burn occurring, meaning permanent photochemical damage can happen without any wanting sensation whatsoever. In 2017, a young woman glanced at the partially covered sun for a few seconds without protection and then briefly used non-compliant glasses. Doctors later found a literal crescent-shaped lesion burned permanently into her eye, mirroring the exact shape of the eclipse. A partial eclipse dims the ambient light just enough to turn off your natural squinting and tearing reflex, exposing the delicate cells of the eye to concentrated solar radiation. The safety protocols are absolute. During all partial phases of the eclipse, you must use ISO 12312-2 certified solar filters. You should never look through an unfiltered camera, telescope, or binoculars, even if you are wearing eclipse glasses. The optics will concentrate the sunlight and instantly burn through the protective filter material. There is only one strictly timed exception. You can look with the naked eye only during the exact brief minutes of totality itself, when the moon completely covers the sun's bright disk. If you are outside the path of totality, which includes almost all of the world for the 2026 event, there is no safe naked eye moment. The filters must stay on for the entire duration. The August 2026 eclipse offers a rare, low-horizon view of a fading astronomical mechanism. Safely witnessing it requires verified protective gear and an understanding of the exact orbital mechanics playing out above our heads.